Today's video is on integration using residues. In today's video, we are going to find the poles and the corresponding residue values for the given function f of z is equal to e power z by 1 plus z square. See here clearly from the question, f of z is given as e power z by 1 plus z whole square. So in order to find the poles, what we have to do? So we have to equate the denominator to 0. So if I equate this denominator to 0, see here, so z value is clearly minus 1. So z is equal to minus 1 is a pole of order 2. So it is a pole of order 2. Now we have to find the corresponding residue for this. So the pole value is z is equal to minus 1. Corresponding to this pole, we have to find the residue value for f of z. For this pole, z is equal to minus 1. So here our formula is residue of f of z at point z is equal to z naught is nothing but limit z tends to z naught 1 by m minus 1 factorial into d by dz power m minus 1 into this is z minus z naught power m into f of z. Clear? So here I am taking m value as, so m is nothing but the order value, m is equal to 2, and z naught value is nothing but the pole value minus 1. So if I substitute in the formulae, so we'll be getting the residue value. So therefore residue of f of z at point z naught is equal to minus 1 is equal to, this is limit z tends to minus 1, 1 by m minus 1. So this is 2 minus 1 factorial into d by dz power, this is 2 minus 1 into z minus, so minus of minus plus 1 power m value is 2 into f of z. So what is our f of z value? F of z value is e power z by, see here, e power z by, this is z plus 1 whole square. Clear? Now I can cancel the numerator as well as denominator and see what happens here. This will be limit z tends to 1 by 1 factorial into d by dz of e power z. So clearly e power z is nothing but the derivative of e power z is nothing but again e power z. So if I substitute, see here, this is minus 1. So if I substitute z value as minus 1, see here, this will be minus 1, and therefore our residue value is equal to 1 by e. Therefore residue of f of z at corresponding pole value minus 1 is 1 by e. So e inverse is the residue value for the corresponding pole value. So here this is minus 1. So this is also minus 1. So if you observe this one, the question given here is f of z is equal to e power z by 1 plus z square. So here in order to find the pole values, we have to equate the denominator to 0. So we got the z value as minus 1, so which is of order 2. So it is a pole of order 2, and therefore in order to find the residue, this is the formula, that is residue of f of z at z is equal to z naught is nothing but limit z tends to z naught 1 by m minus 1 factorial into d by dz power m minus 1 into z minus z naught power m into f of z. So here m value is the order value 2 and z naught value is the pole value minus 1. If I substitute each and every term here, and we have to make a derivative for the left function e power z. So e power z derivative is again e power z, and if I substitute minus 1 in place of z, so I got e inverse which is equal to 1 by e. So this is a residue value corresponding to the pole z is equal to minus 1 of order 2. Thank you so much for watching. Hope you guys understand. If you really understand, you can do many problems of this kind and you can score more. Pass it on to your friends and subscribe to this channel and have a look at my another video which will be posted very soon. Thank you so much.